This video will build an intuitive understanding of infinities and construct a solution to the tricky submarine puzzle. The puzzle will lead us to profound discoveries about the fundamental nature of numbers, and in the end, we'll solve another dazzling puzzle about infinite mosquitoes and a laser pointer. Let's dive in. You are hunting a spy submarine. It moves along the integer number line at some constant velocity v, starting from some unknown position x0. The submarine moves v steps each second, and we get to search one number after each move. Our task is to somehow find a search pattern that is guaranteed to eventually find it. Are you ready for the fascinating solution? Let's catch that submarine. Just testing some different search strategies may be a good way to get used to the rules, but with a complex puzzle like this, it can quickly become overwhelming. The possibilities are just limitless. Random testing will typically be unfruitful. A good problem-solving strategy is to simplify. Let's consider the stationary case, where the velocity equals 0, and see if it gives us some insights. The submarine can still be at any integer, and somehow we need to search through them all. Perhaps we think, let's first search the positive numbers and then the negative. At time 1, we check 1, then 2, 3, and so on. The problem is, this will literally take forever, and we'll never get to the negative numbers. You might then say, let's just start at infinity and move down from there. But infinity isn't a number. Whatever you suggest starting at, the submarine may have started at that plus 1. But there is a way. We can search both positive and negative in parallel, like this. Search 0, 1, minus 1, 2, minus 2, and so on, interlacing the positive and negative numbers. Like a dancer hopping back and forth. This way, we will eventually find the submarine if the velocity is 0. We're making good progress. Now, let's add some complexity. Let's now consider the case where the starting position is 0 and the velocity is unknown. Let's visualize the possibilities. After the first second, the submarines could be at any position. The velocity could be any integer. Somehow, we must eliminate all possible v. But we just learned something useful. We can reorder to get 0, 1, minus 1, 2, and so on. So after the first second, let's search 0. But then things get a bit trickier. The submarine moves. This isn't really an issue though, as long as we keep track of time. We simply scale the velocity we want to eliminate by the time that has passed to figure out where the submarine should be. So at t equals 2, we eliminate v equals 1 and search position 2. T equals 3, search position minus 3, eliminating velocity minus 1, and so on. Going through all possible v, searching v times t. And this also works. We've now successfully found a strategy to find the submarine for unknown velocities, as long as it starts at 0. We're getting really close to a full solution. Let's now combine our learnings and solve the full puzzle. Unknown starting position and velocity. Both x0 and v could be any integer. Here's the beautiful insight. Every possible submarine behavior is described by exactly two numbers. Its starting position, x0, and its velocity, v. Scaling just like before, after t seconds, it will be at position x0 plus vt, the starting position plus however far it's traveled. But how can we systematically search through all possible pairs of starting position and velocity? I'll actually show you two different approaches to this. First, remember our alternating pattern? Let's take two copies of that and create a grid. One list for x0 and one for v. In this grid, every point represents a combination of x0 and v. Importantly, every possible combination of x0 and v is in this grid. For each point, we just need to search x0 plus v times t. For example, at t equals 5, if we want to eliminate the possibility 1, 1, we should search position 6. To cover all options, we can do something like this. Snake through the points in a zigzag fashion. If we just keep track of time, we will have all the information we need to eliminate each option. We will eventually go through all the possibilities, and so we are guaranteed to find the submarine. We've won. I promise you 2 approaches, so let's consider a different perspective. So we want to search through all possible integer pairs x0, v. We could just plot the plane of 2D integer coordinates. Like before, each coordinate represents a pair of x0 and v. And here it might be even easier to visualize the search pattern. See if you can figure it out for yourself. It's just a spiral growing outwards. We will again pass through all possible pairs. So we again did it. We managed to find the submarine. I'll share a third beautiful method in the comments, and maybe you have your own. What we've just discovered goes far beyond catching submarines. We've stumbled upon what mathematicians call countable infinity, an infinite set which can literally be systematically counted. Let's call this infinity type 1. So, for example, clearly the set of natural numbers is countable, basically by definition. So we say that the size of the set of natural numbers is infinity type 1. Make sense? What about the integers? Well, we already discovered that just reordering them lets us count them. So the size of that set must also be infinity type 1. What about 2D integer coordinates? Well, we just did that with x0 and v. They were just any integers. That's the spiral pattern, which you just showed. So it must also have size infinity type 1. Here's where I think it gets really mind-bending. Let's consider rational numbers. It could be 1, a half, 2/3, 22/7, anything that can be written as a over b, where a and b are integers. A simple change of perspective shows us that they are also countable. And keep in mind that between 0 and 1 there are infinitely many rational numbers. The natural numbers are a subset of the rational numbers. Yet, in some sense, they are the same size. What does that even mean? So a natural question might be, are all infinities type 1? Let's check the real numbers, rationals and irrationals. If they are countable, we can put them in a list. Let's now construct a new number, n, by taking the first digit in the first number and adding 1 to it. In this case, 1 becomes 2. Take the second digit from the second number, in this case 6 becomes 7, and so on in this diagonal fashion, adding 1 each time. If it's a 9, we'll just make it a 0. This number we just constructed is different from all numbers in the list. By definition, it differs from number 5 in the 5th position and number 100 in the 100th position. So it differs from every number in at least one spot. But this number should have been on the list, it's clearly a real number. So the only conclusion is that such a list cannot exist. You cannot make a list of all real numbers. So the reals must be uncountable. This is a really fascinating result. Let's call the size of the reals infinity type 2. Hold up. Infinity type 2? How do you know there's no infinity between type 1 and 2? Actually, this is what mathematicians call the continuum hypothesis. We think it is this way, but no one can actually prove it. In fact, we can show that given the current mathematical tools, it's not even possible to prove. But hold up. You said infinity type 2. Like 1, 2, 3? What do numbers even mean anymore? How many types of infinity are there? Are there countably infinitely many types of infinity, or even more? We will have to save that for another video, but I do want to tease you with the expression 2 to the power of infinity type 1 equals infinity type 2. Think about what that means. Does that continue to work? Alright, so we solved the puzzle, but many new questions appeared. Isn't it fascinating how the same idea of counting rocks in ancient times has now brought us here, to the edge of mathematical knowledge? Infinities are strange. Can you solve this puzzle with the tools we just developed? Consider again the plane of integer coordinates. You stand at the origin with a laser gun. At every point sits a point-like mosquito. The puzzle is, can you point your laser in a direction such that it doesn't hit a single mosquito? Can you solve this puzzle before my next video? Subscribe for more puzzles like this. Thank you for watching.